Let's take a few minutes to talk about what this balanced equation, or this equation when it's balanced, what it can mean. First of all, we see that it is not balanced. We have two n's here, so we will need a 2 here. We have two h's on the left, and on the right we now have 6, so we're going to put a 3 in front of the h2. These numbers in front, if you recall, are called coefficients, and the lower numbers below are subscripts. When you're balancing equations, you add coefficients. If there is no number in front of a formula, it's assumed to be the number 1. We don't write ones, but it is understood that there's 1 N2 plus 3 H2s making 2 NH3. So this is a balanced equation, and we are going to start using the balanced equations for some further calculations. In fact, we're going to be looking at them, and we're going to understand that they give us a thing called the mole ratio. This tells me how many moles of each substance I have to add together in the case of the reactants to make the number of products. It tells me how many molecules even, and it could be a molecule ratio, but we're going to focus on the mole ratio. What this is telling me, this balanced equation is giving me some conversion factors, if you will. It's telling me that every time I put 1 and 2 into there, I will need, in order to make the reaction go, I will need 3 H2s. And every time I put 1 and 2 into there, I will get 2 NH3s. And every time I put 3 H2 into that reaction, I can go backwards and get the N2. I will also yield 2 NH3s. So this is another way of looking at information that is provided from our balanced equation. This information can be used to help us do some conversions. If I wanted to say, all right, I have 12.5 moles of N2, and I want to know how many moles of NH3 I can make, I can do that. I take my 12.5 moles of N2 and I make it over 1 to do a regular conversion. And using this mole ratio information, I can go from moles of N2 into moles of NH3. I'm going to put moles of N2 on the bottom because I want to cancel my units. And then I can put moles of NH3 on the top because in my list here I have a equation or a conversion factor that equates N2s and NH3s. And I see that I have 1 N2 will get me 2 NH3. And because this is a molecule ratio or a mole ratio, I can use that information to make a conversion, just like I could have done 12 inches equals 1 foot. If you go back and you look, I have canceled my units and I'm left with moles of NH3. So to finish this problem, I am simply going to take my 12.5 times 2 and I would get 25 moles of NH3 is what I'd produce if I put 12 moles N2 into this balanced equation. So the information provided in a balanced equation is conversion factors for that particular situation, and we're going to use that information, our mole ratios, in order to do some more detailed and more complex conversions called stoichiometry. So I'll write that out because it's a long word, stoichiometry. And that is what we're going to be working on over the next few days.